So to do a problem like this, we're going to write, just like it says here, let me highlight it. We're going to write two equations, or a system of equations. Okay, then we're going to graph them. Okay, we're going to write them, we're going to graph them, and when we do that, they'll cross at some point, and that'll be our solution. Let's read. Just follow along while I read the problem. Two road crews are paving a straight section of highway. The first crew is responsible for paving the eastbound lanes, and the second crew is responsible for paving the westbound lanes. The first crew has already paved 30 miles and is paving 2 additional miles per day. The second crew has already paved 60 miles and is paving an additional 1 mile per day. After how many days will the two crews have paved the same amount of road? I'm going to make another note like we did before here, that we're not going to use X and Y for variables. But let me make a note of that, like I said. And the reason we're not going to use X and Y, even though this says X, we're going to use D for days. Even though this has a Y up there, we're going to use, instead of distance, we don't want to use D again. We will probably use M for miles. Okay, so I want to make a little note so we can remember what those variables stand for here. Right. Let's use D to represent how many days. Let me go move this over. Oops. How many days? And also let's use M to represent how many miles. Okay, keep that up there so we'll remember. Now we can set up our two equations. We'll do one in blue. The first one, the first crew in blue. Let's see here. Okay, so for the first crew, the number of miles, M, that they work on, or that they complete, that they pave. And let me show you where I'm getting this. It says it right here. The first crew has already done 30, and they're going to do 2 every day. So their equation will be the 30 that they've already done plus 2 times the number of days, because they do 2 every day, 2 miles a day. Okay, and we don't need this other circles right now. These other, for now, we're going to use a different color. The second crew, that'll be like orange. Okay, the second crew. The number of miles that they will have paved, let's remember because I already forgot. The second crew already did 60, and they do 1 each day. So their equation will be the 60 that they've already done plus 1 every day. So now we've done that first thing that they said that I highlighted with yellow there. We've written 2 equations. We've written a system of equations, and we can graph them. The way we graph them is by using the slope 2, or 2 over 1, and the intercept. So let me write what I just said. For that blue crew, for the first crew, the slope is 2 over 1. Now there's I guess we can say it's a little bit of a problem, but we're going to fix it. This graph doesn't go over by 1. It goes over by 5. If you look down here at the bottom, right, we go 5, 10, 15, 20. We go over by 5 or 10 or 15 or 20. So we're going to have a fraction that has a 5 or a 10 or 15 or a 20 in the denominator. It'll still be equal to 2. And I want to say that another way. Is it always going to be over 1? No, they could have a different slope. But for word problems, the answer is we could have a different slope. We don't now, and that would make the problem harder. But no, it could happen. They could have said they do 2/3 of a mile each day. They didn't, thankfully. But yeah, they could. We could have used a different slope. Anyway, let me just write 2 in another way. If I wanted to have a 5 on the denominator, okay, in other words, if I multiplied the bottom by 5, 1 times 5 gives me 5. I'd have to multiply the top by 5 also. 2 times 5 is 10. Now let's see if that will work. On this graph, if we start at 30, let me make a blue dot at 30. 10, 20, 30 would be right there. Could I go up 10 and over 5? It looks like we can, right? I can go up 10 and over 5. That makes sense? So I can do that. I'm gonna do that since we can. That'll put a point right here. And while I'm at it, let me just keep doing it until I run out of room. Up 10 and over 5. Up 10 and over 5. It'll just take me a second. When you do this with IXL, you only need to make 2 dots. You don't need to make, what did I do here? 1, 2, 3, 4, 5, 6. You don't have to have 7 or 8 dots. But since I don't have the IXL tool handy right now, I have the old-fashioned ruler. That's what I'm going to do. And so let me make a thin blue line there. Once I line them up, I don't want to spend all day doing this, but it's going to be close enough right there. There we go for our blue line. Now, let's talk about the slope for the orange crew, the second crew. That slope for the orange crew is 1 over 1, right? And same as before, the scale doesn't go over by 1 day. It goes over by 5 or 10. So we're going to have to multiply the top and the bottom by 5 or 10 or whatever will work. 5 will work here, won't it? Actually, no, I'm sorry. 5 won't work. We can go over 5, but we can't go up 5. So can we also do 10 over 10? That's also equal to 1, isn't it? Okay. So we'll want to start here at 60 for the orange graph. We'll want to make a dot here, a point here at our intercept at 60. There's 40, 50, 60. And we'll want to go up 10 and over 10. Wait, did I make a mistake there? I think oh yeah, up 10 and over 10. Sorry, I did not make a mistake yet. Up 10 and over 10. Right? Let me say that again. I went up 10 and then over 5, 10. See that? So that's why my second orange. Go ahead. The answer is the question is, why do we always multiply by 5? And the answer is, I didn't always multiply by 5. This time I multiplied by 10. And the reason why is because this scale down here, not all of them do this, but this scale goes by 5 or 10 or 15 or 20, whatever. So we have to have one of those numbers in our denominator. Okay. And we also have to have one of these numbers, this goes up by 10 or 20 or 30. So we have to have one of those numbers in our numerator. And the important thing, the way I want to say this another way is that in any math problem, there's almost always more than one way to express something. We expressed 2 over 1. That's one way to do it. But 10 over 5 is the same thing as 2 over 1. It's expressed a different way is all. Likewise, there's another way to write 1. Well, 1 over 1 or 5 over 5 or 10 over 10. Which one will work on this graph? In this case, with the orange, it's going to be 10 over 10. Up 10 and then over 5, 10. So that's where my next, I need to switch to orange. That's where my next orange point will be. Let me get rid of this. So up 10 and over 10, up 10 and over 5, 10, up 10 and over, oh, there's already a dot there. And one more time until I run out of room. So now let's line those up with my ruler, make my graph. A little bit down, maybe. Come on, ruler. I hate this ruler. It's messing with me. Good. Okay. Whew. All right, there we go. Yes, those are the number. The question is, do we always start off with 30 and 60? Well, let me just say, in this problem, we start off at 30 and 60 because, let me highlight it with a yellow here, what we're talking about. Yes, these two numbers are the, yes, you can say they're where we start. The technical word is the intercept. And I want to say that word again, intercept or intersect is where our lines, the blue line and the orange line, intersect the y-axis, where they cross the y-axis or touch the y-axis. The orange, let me get rid of that highlight there. The orange line intersects or crosses or touches the y-axis at 60, doesn't it, when you see that I drew it there? And the blue line touches or intersects or crosses the y-axis at 30. And when you see that blue line that I drew, yep, it does. So yes. So I don't want to use the word always because there are going to be different numbers when we do other problems. Anyway, now that we've done this, it's clear to see, I think, that right here is where those two lines intersect. Okay, and we have where we would normally say x and y. We say we're not going to use x and y in this problem. We're going to use d instead of the x, and we're going to use m for miles instead of the y. So isn't the d value 30 as in 30 days? Oops, I don't know why it auto-corrected there. And isn't the m, I'm thinking 90 as in 90 miles? Okay, and so we could answer either question. It depends on what they ask, and we'll go back and read what it says in a second. If they asked us how many days it took, we would say 30. If it asks how many miles they did, we would say 90. Let's see, what did they ask? Right up here, it says, after how many days? Oops, after how many days? Well, they had the same amount. See right there, it says how many days? So the answer is after 30 days is how many days it would take for them to have paved the same amount of road. In other words, the answer is 30 days. Good question. Why did we go up 1 and over 2? And the answer is we didn't go up 1 and over 2. We went up 10. Watch this. When I do this, I'm going to use a different color here. When I go up that much, I didn't go up 1, right? If I go from here to here, that's not up 1. That's up 10, isn't it? And when I go over, when I start here and go over, boom, boom, I didn't go over 2. I went over 5, 10, didn't I? Yes. And I want to say this another way. We have to be very careful to look at what that scale, that's the technical word, what that scale is. Those little tick marks don't always equal 1. I know we usually use 1, but sometimes to fit more stuff on here, I mean, if you look at the axis over here, right, it doesn't go up 1, 2, 3, 4. It goes up to, 10, 20, 30, 40, all the way to 100. But that same distance over here isn't 100 because it doesn't go by 10s, it goes by 5s. 5, 10, 15. So we have to pay close attention to those. They did it that way so they could fit more on the graph. Anyway, the answer to the question is, like I said, I know I have a lot of stuff here. The answer to that question is 30. 30 as in days. 30 days is how long it takes.